Okay, unbalanced three-phase system. So what is it? Is basically you change the load. Instead of the same load, you just use different load. That is means by unbalanced system or unbalanced three-phase system. Okay, so for this case, instead of just using one parameter, you have to calculate for each line. Okay, so this one is line phase current. Okay, phase current is equals to the voltage phase voltage divided by the individual load. So you have to calculate one by one, okay, using Ohm's law. Okay, and for this case, this is for there are star-star connection. Star-star connection with 4 wire. Remember that I said star-star connection, you have two types. Okay, you have the star connection. Okay, something like this. Okay, this is 3 wire. Okay, and there are another one is called 4 wire, means that you have neutral wire. Okay, so if you have neutral wire, it is much more easy. And here is the Kirchhoff law for this. Okay, if you look here, this one is IA, this one is IB, this one is IC. Okay, neutral wire, this is IN. So IA plus IB plus IC plus IN is equals to 0. Okay, Kirchhoff Current Law. So basically IN is equals to negative IA plus IB plus IC. Okay. For balance load, okay, this is important. For balance load, balance, okay, IN is equals to 0. Okay, there is no neutral current. But if you are unbalanced load, okay, IN will not equals to 0. Okay, so you need to be careful. So basically, this one is the practical one, because for three phase, usually we don't see a balanced load. Okay, usually it is unbalanced. Okay, because usually the three phase. Okay, our system use three phase. Okay, but when it comes to distribution, okay, if the housing use a single phase, means that this one goes to, for example, you have 10 home. Okay, if 5 home, 1, 2, 3, 4, 5. Usually they will give phase A to 1, 2, and 3, phase 2 to 3, 2 and 4, something like this. Phase another phase is goes to 5. Okay, so it will be unbalanced. Okay, some user use a lot of energy, some user are not. It will become unbalanced, and the neutral current will be here. Okay, there will be neutral current. Okay, now we move on to the how to calculate the unbalanced load. So I take here. Okay, okay, for unbalanced load, unbalanced Y load. Okay, you have star load, means that you have something like this. Okay, this is Y load. Okay, has a balance 100-volt voltage and the ABC sequence, ACB sequence. Okay, this is negative sequence. It should be flipped, but I suggest you don't look at this example because it is confusing. Okay, because this is ACB sequence. So be careful, ABC and ACB. But usually we will ask the ABC sequence. Okay, so just take the notes first. Okay, this one is ZA is equals to 15. Okay, this one is ZB equals to 10 plus J5, and ZC is equals to 6 minus J, 8. This one is A, this one is B, this one is C. Okay. So 100 volt, balance 100 volt. This one is also not very good. They should mention whether this is a phase voltage or line voltage. Okay. But for this case, I think this, okay, I think this one is a neutral one. Okay, if we look at figure 12.23, 12.23, okay. So you can see here, okay, they have neutral wire. So if you have neutral wire, it is much more easy. So this is neutral. Okay, and then this one has a balance voltage of 100. Okay, this one usually is not very good because they should mention whether this is the phase voltage or line voltage. Okay, if based on the calculation, this is a phase voltage, means that this one, okay, I use a different color. This one VAN, okay. This one is VBN, and this one is VCN. So if you have positive sequence, okay, this one is negative sequence. So ACB sequence. Okay, if you have ACB sequence, means that VAN is the same, equals to 100 angle 0 degree. Okay, VBN is 120, 100 angle 120 degree. Okay, VCN is equals to 100 angle negative 120. So it is counterclockwise. Okay. So make sure you be careful. If they ask you to calculate using negative sequence, you use ACB sequence, you use this one. Okay. If you have if they ask you ABC sequence, you should be negative and positive. Okay. Only flip B and C. Okay, and then you calculate the current. Okay, you already have the phase. Remember that I said if you already have phase voltage, automatically you can calculate the phase current. Okay, how to calculate phase current? Of course, using Ohm's law. IA is equals to, okay, let me check whether I record this or not. Okay. Okay, IA VAN divided by ZA. B is equals to VBN divided by ZA. IC is equals to VCN divided by ZC. This one is ZB, sorry. So you have to calculate one by one. VAN is 100 angle 0 divided by 15. Okay, this one 15. IB is 100 angle 120 degree divided by the load for ZB is 10 plus J5. Okay, ZC is 100 angle negative 120 divided by 6 minus J8. Okay. So the question asks you to calculate the line current. Of course, you already calculate the line current. You have to use your calculator to calculate this. Okay. And then after that, you have to calculate the neutral current. So how to calculate neutral current? Just use the formula. Okay. IN is equals to negative IA plus IB plus IC. So you just add everything. Okay. Add everything and you get the answer. Okay. For unbalanced load, the current should be not 0. Okay, you can see here the answer is negative 10.06 plus J 0.28. Okay, make sure you be careful with the label. Okay, make sure you be careful with the label. Okay, the label is all go in. Always label all go in, even the neutral. Okay, we move on to another example here. Unbalanced delta load of figure 12.24. This one, okay, is supplied by a balanced line-to-line voltage. Okay, this one is good because they mentioned that line-to-line voltage 240 means that this is line voltage. And it is a positive sequence. Positive sequence means that ABC, okay? Negative sequence means that AC, B. Okay. So let me look here. Okay, so of course you already have the voltage, or you want to draw it, okay, because it is easier for you to see. So this is the load. Okay. So remember A, B, C. Okay. So current IA, IB, IC. So how about the voltage? It is line to line. So means that this one is VAB, VBC. Okay, remember line the arrow is from C to B. Okay, negative to positive. And then the last one is VCA. Okay. So positive sequence, okay, because of the positive sequence, you calculate VAB is equals to 240 angle, okay, 240, they mention the amplitude, the angle you have to set to 0. VBC, positive sequence means that you start with negative, okay. VCA is 240 angle 120 degree. Okay, this is for positive sequence. Okay, now you already have the phase line voltage. Okay, for delta line voltage and line current, line voltage and phase voltage is the same. So means that this one is V line is equals to V phase. Okay. Now you already have the phase voltage. Okay. Because you already have the phase voltage, you can easily find the phase current. Okay, IV. Phase current I A B. So this is IAB. So be careful, IAB. This one is IBC. This one is ICA. Okay. Be careful with the arrow. So from B to C. So IAB is equals to, let me check first, okay. So IAB is equals to VAB divided by ZA. Okay. Let me move this. Okay. ZA. IBC is equals to VBC divided by ZB. ICA is equals to VCA divided by ZC. Okay, always use the first letter. So remember, ZB, IAB, ZC, ICA. Okay, first letter. This one, make sure you remember. Okay, we move to the next part. Okay, you use your calculator to calculate this. So VAB is 240 angle 0 divided by ZA. Where is ZA? So ZA means that, okay, for this case, I suggest you use ZAB, the same. Okay, because this is delta. So I suggest you use ZAB juga. Okay, you use ZLB also. So ZBC, ZCA. Okay. Now 240 divided by 10 minus j pi. Okay, this one take from this one, and 240 divided by 16. Don't forget the angle, negative 120 degree. ZCA is 240 angle 120 degree divided by 8 plus j 6. Okay. So use your calculator, give me the answer. So what is the answer here? Okay, practice with your calculator. Find the first answer. So anyone get the answer already? Get it or not? Okay, how about Mosadat? Can you answer it? So what is your answer? The answer, this one? Press your
7. What's
calculator.
the numerator? What's the number in the numerator?
You have to show in rectangular form. The one with the angle.
What's the number on top?
What?
Number on top.
240 divided by 10 minus j5.
Second doctor.
So what is the answer?
19.2 plus
19.
9.6 J.
Is it correct? (240 divided by 10 minus j5). Okay, make sure you
19.2 plus 9.6 J.
19.
19.2 plus 9.6 J.
It should be this one. 7, right? Angle 26.5.
Oh, in rectangular or polar?
Oh, sorry. Polar form. The one with the
Oh,
angle. Yeah.
oh, okay, 1 second.
Okay, current and voltage. How I can show this? Okay, V and I. This one in R angle theta. Z should be X plus J Y. Okay. Usually we represent like this. Okay. For S, complex number, complex power, both. Okay. Okay, but the answer is not the same. Why is not the same? It should be the same, right?
Yeah, like my answer was like rectangular form. So
your answer get the same? 21.47 angle 26.57.
I'm gonna try right now. I'm trying. Um, 21.47.
Okay.
Angle is 26.57.
Okay, so something wrong with the answer.
No, try it. For the first one. 21 point.
Yeah, this one and this one is not the same, right? You can see here.
6.56.
Find the line current.
Oh, yeah.
Right.
Yes,
Oh,
yes.
okay. They want the line current. Sorry. They want the line current. This is phase current. So remember, that's why we still don't get the answer yet. So we calculate the phase current. Okay, it's okay. Just we continue. Okay, the second one is 15 point angle negative 120 degree, and the third one, okay, third one is 8 plus 6i. So this one is 24 angle 83.13 degree. Okay, make sure you practice with your calculator. So now the question asks you to find the line current, not the phase current. So let me adjust this first. So you already have the phase current. Now you have to find the line current. Okay, I line. So if you, this one is unbalanced. Okay, unbalanced, you cannot use the I line is equals to square root 3 I phase angle. Okay, sorry, I forget the formula. I phase multiplied by square root 3 angle negative 30 degree. So you cannot use this. This formula is only for balanced load. But for unbalanced load, you have to use the original formula. Okay, so you have to apply Kirchhoff current law. So if you look back here, okay, if you apply Kirchhoff current law here, okay, at point A here, means that IA is equals to IAB minus ICA. Okay, the trick is, I suggest to you, you just remember something like this. Okay, if you still cannot remember it, IA is equals to IA and then minus IA. Okay, so because you are using positive sequence, so IA, AB, oh, B, IBC, ICA, so CA, something like this. This is how you remember how to do this. Okay, so IA is equals to, you have to look back this formula, your equation at the top, you already calculate. Okay. So where is it? Okay, let me adjust this. Okay, IAB is 21.47 angle 26.57 minus ICA is 24 angle 83.13. So someone calculate it and give the answer to me. Okay. How about Nuria? Calculate it. Can you calculate this? Or anyone? If you can calculate it quickly, give it to me, the answer. Okay, nobody can answer this? Just use your calculator. Okay, The answer is should be 21.66. Okay, angle negative 41.06 ampere. This one. Okay, you already find the line current. Okay, so you apply the same concept here. IB is equals to IB minus IB. Okay, and positive sequence AB, BC, okay, and CA. So IA, B. Okay. Let me move it a little. Okay. So the same concept, you just apply it and then you insert the value. IC also the same. IC, you don't know what is the value, and then I don't know C. Okay, ICA. So IA, IB, BC. Okay. So use the sequence, positive sequence. So that is how you find the line current. Okay, so this is another example. Okay, it's already 12 o'clock. We take a break around 10 minutes, and I will continue with this type of circuit. So for this type of circuit, we have to use a mesh analysis. Okay, I will show you after 10 minutes. We meet again at 12:10. Okay, so take a break.